So here we are. We were there and we saw that one. You can see, I'm going to mention something for you here. You can write long division and many things here, and you found it. Now we have another example, also contain many ideas actually. And we saw that example in chapter 5, I think, or 7, let me check. In chapter 5, example number 6. Yeah. The same idea here, example number 6 and example number 8. Both look like each other. But example number 8 is easier in chapter 5. So how we solve that example? I'm going from the easy idea or the simple idea to the complicated one. So how we solve that one? That example is in Cal 1, chapter 5. How we solve that one? Do you have any idea? Okay, but that one. Think about it. You are right. For the 6, I'm going to ask you again. Thank you. But how about that one? So how we solve that one? Exactly, easy. We are going to bring it to up. So I have what? 2z dz, 2z or z dz over over z squared or z squared plus 1 cubic root plus 1. Because I have a z square and I have a z up, so I'm going to think about bringing it to up. So I'll get what? I see is equal to z squared plus 1 minus 3 2z dz. Now I have a box, d box, right? Box, d box. So u du. You can say u du, up to you. So I'll get what? Z squared plus 1 minus 2 over 2 plus c. Understood? Then, yes, so sorry, 1 over 3. So it's going to be what? It's going to be minus 1 over 3 plus 1, right? And I'll get what? Minus 2, or sorry, 2 over 3. Thank you. So that one will change to 2 over 3 and 2 over 3. And later we can reverse the denominator. Do you have any question? Easy, because you have a z dz. How about example number 6? It's contain good idea. How you solve that one? X, 2x plus 1. يلا دي. Separate them. How? يعني x dx, okay. Okay. Any other idea? Yes, we should solve by you do, but later tell me how. That one is kafir. Thank you for making that mistake, because later I know most of you do it. So kafir, why? It's taboo. Why? Because for division and multiplication, we cannot distribute integral. Integral cannot distribute, just we have for addition and subtraction. So that's why is kafir. First. Okay, second idea, you say u du. Let me check how. Tell me, where's u? Inside that square root. Okay, I'm saying let u be 2x plus 1. Okay. And du is equal to what? 2 dx. Okay. So how about that x? That one, how we solve that? X minus 1 over 2. Thank you. So x minus, not x, u, right? Did you understand what did he say? Do you have any idea why we changed that one? Okay. Forget that idea, which is correct 100%. But tell me about another idea. Because if you don't know why, if you can't think about another method, you cannot understand that one. That's why I'm stopping the correct way. So do you have any idea to solve that one? Forget about all these things. Do you have any idea? Another method? Why we are not going to solve this one by box dbox? Why? Yes. Exactly. Thank you. Briefly, she said, because the derivative of that box is not x something. Understood? Dear? For example, let me give more things. 2x plus 1, 1 over 2x dx. That's my question, right? I just arranged it. So derivative of here equal to 2. How about this extra x? I cannot bring it to out. I cannot separate. So how we solve that one? How we change that one? Right? So there's a problem. There's an extra x. You got the idea? That's why I cannot solve by u du, box dbox. Let me say that one. That's why I don't say u du, because later we have u du. That's why we say box dbox. You cannot solve it. Any other idea? No, we cannot solve that one. So because we stuck, right? We stuck here again. We cannot solve or use any other method. It's not the direct, it's not the indirect, it's not a formula like a sine inverse, cosine inverse, tan inverse, right? Not hyperbolic, none of them, none of the table 8.1. So it's not direct, indirect, no. Formula, no. So I'm going to use u du, as they say. I'm going to use du. Okay. There's a problem with a square root. That problem is here. So I'm going to fix the problem by letting. So I say let here be u. When you do let, now we should change that example from x to integral by u. Everything should be u. So here we have, I'm going to write down again for you, but in a little bit here. We have x, 2x plus 1 dx. I'm going to change by, understood? Everything, every single x should be changed to u. So how? I said let, this let is very important. Let u be 2x plus 1. From here, I can change dx to du, and I can change x to something u. That's why. So I say if I have that one, I'm going to use to find du. I will get what? 2 dx, right? But I need 2 dx or I need x. I need 2 dx or I just need dx because I want to change dx. Of course, I say dx is equal to what? By dividing both sides by 2. Understood? So now, to be more clear for you, now I say the square root changed to u. Do you agree with that one? Hello? It's clear? That changed to u. So I have square root of u. Do you have any problem with that one? Now I need to change dx to something. So I don't know dx is equal to what. I say du is equal to 2 dx. So dx is equal to what? Du over 2. So again, I have du over 2. Do you have any problem with here? Again, now it remains what to change? Only the single x, right? So it's equal to what? From here, I say 2x plus 1 equal to u. So 2x is equal to u minus 1. So x is equal to u minus 1 over 2. Am I right? So I'm going to write here u minus 1 over 2. Do you have any problem with it? Do you understand? We change every single x to u, dx to something du, square root to square root of u. Why? Why we do like that? Why I did all these change? Yes? Yeah. So okay, we cannot do it. So we do like all these change. Here we are. We have all these change. We have u minus 2. We have square root of u. We have du over 2, right? So why? Because we think after this change, I will get an easy integral, or I can solve the integral. That's right. Look at, am I right or not? So 1 over 2, 1 over 2. Hello? 1 over 2, 1 over 2. Well done. 1 over 4. So why u minus 1? 1 over 2 du. Do you have any question about that step? Okay, now it's time to what? Left multiplication, sorry, right multiplication. So I get what? Do you have any problem with that? I just multiplied and I separate. Because we have what? Subtraction. We have subtraction. That's why we can separate, or we can say distribute. We distribute integral over subtraction. Okay. Now I get what? Is equal to what? That integral. Hello. Yes, is equal to? Am I right? How about the other one? Understood? Because easy, huh? We took the integral. We finished our integral. That's why. So in that case, I'll get what? 1 over 4 Tell me why. Instead of each u, I have what? Because we say u is equal to 2x plus 1. That's why. We just substitute. Because I gave you integral with x. I didn't say solve for me by u. You did that one, good. You make it easier and you solve. So later, the last step is what? You should substitute. That's all you need. Understood or not? This is in the example 1, chapter 5 in your calculus 1. The same idea we have here. Look. We have the same idea. So we change that one to u. We have du, but that one is easier. Easy. It looked like example 8, not example 6. So, and we change that one. Look. We separate them because you have addition. Here's the separation. Then that one derivatives exist, that one derivative not exist. So I'm going to solve for you instead of speaking. Let me solve for you. We have the integral of 3x plus 2 over 1 minus x squared dx. Directly, I'm going to make it two parts. Why? Because I think it's easier for me. How we mix examples. Look. how we use 2 or 3 ideas together. Look, yalla. How you solve that one? Look at the difference between first integral and the second integral. If you don't know how to solve that, I mean you didn't understand 8.1 again. So check yourself. You need more exercise, more study. So I say box d box. How about that one? How about that one? Sine inverse. I solved that one 5 times for you. So welcome. Just look at me. Because a is equal to 1. Understood? Look at that. A equal to 1. How about that one is equal to box? But we need what? Derivative of the box is equal to what? Minus 2. So minus 2. And I will get what? Minus 3 over 2. I'm a B. Careful. And 1 minus x squared. No. We add 1 over. We add 1. So minus half will be half. Right? And 2 sine inverse of x plus c. So that's all that we have. You can see he changed it to u to understand. And this is the second one. And here's the result that you need to find everything. Do you have any question? Do you have any question? No. How about that example? How we solve that one? We should use the idea of example 6 in chapter 5. We cannot solve that one. 1 plus, I don't check, square root one plus square root of x, all of them with power 3 dx. So any idea to solve that one? I have a fraction. Does the ln exist? No. The ln does not exist, right? Can I bring it to up? Yes, bring it to up. But look at what we have. Fermo. So is box d box? Derivative of the box is equal to what? Yalla. Say. Derivative of the box. Forget about the minus 3. No. Derivative of the box, I say. 1 over. So I'm asking myself on dx. Asking myself that one is exist here. So box dbox is not working. So what shall we do? If it's not fraction, if it's not a ln, if it's not anything, what shall I do? Let it by u. Let it be u. Let u be here. Again, like example that's example number 6. So I say let u be square root of x, then du, 1 plus x, and du will be what? As we say, dx. Am I right? And how we change that to u integral? Hello? How we change that one? So I say it's equal to u to power 3 by minus. Am I right? Here u, that's minus 3. Okay. So how about changing dx to du? How? How? So exactly. So I say du, I say dx equal to 2 square root of x du. Am I right? But also we have a problem here. We should change that x to what? How? You have just one lid. Use that one. You have one key. Here's the key. Here's the key. How? I said before 1 plus x, right? So square root of x is equal to what? So 2. It was easy. So now I'm going to change that one. I say I have u to power minus 3 2 u minus du. Now everything changed to u and you can solve that. The same idea in example number 6, chapter 5. So you need to practice because those ideas will be in your exercise. Don't forget about example, that one. Forget about that example. Is not included for you for now. Okay. Because using formula, we don't have this theorem in chapter 8. So you will face such example, maybe here, there, I don't know, by using idea of u. Later, I'm going to select such exercise for you. That's all about today. Thank you for listening. And I need to take attendance. Wait. So, repeating again, dears, you need to review all these things. Otherwise, in 8.2, you cannot solve anything. Yes.